Okay, so yesterday you guys had the lesson on collecting like terms, and the homework was up to page 3. I did mention that I want to take up number 19 because we will go through like these type of examples again and again and again when we do linear relations. So I want to make sure we know how to set up equations like this. Expressions. Okay, Sienna earns $17 per hour at her summer job. At the end of each month, she also receives a $100 bonus. So this is the $17 per hour and then $100 bonus. For the other friend, Marcel, it's $15 per hour and a $200 bonus. Okay, so you have two scenarios right here. For the first one, Sienna, who can give me an expression for her earning? Okay, based on the $17 per hour and the 100. Who can tell me an expression? Shrenik, can you give me an expression for Sienna, please?
Yeah. Well, since she earns $17 per hour, we multiply t by 17 to get 17t.
Good.
And at the end of each month, she receives a $100 bonus, so we just add $100 onto that.
Perfect. Do I need another variable for the 100?
No, it's just
right. So this there's two ways to see it. If you do want to say for each month, then you could add an extra m. But in grade 9, we always only deal with two variables, which is like cost or earnings and the time. So if you introduce a third variable, then it becomes 3 variables, two equations, 3 unknowns, and it's unsolvable. All right, so we just leave it as the 100 as like a one-time add-on. Okay, what's the difference between expression and equation?
an equation has an equal sign to some amount of variable.
Right.
Expression doesn't have.
Right. So right now we're just building expressions. Later on in chapter 5, we'll do equations where it's like earnings equal this. Okay, so for the same format, then what is Marcel's? Aiden?
15t plus 200.
15t plus 200. Good. Right. So write a simplified expression to represent the combined earnings. So combined earning meaning I'm going to add the two together. So this polynomial plus this polynomial. Okay. And so what goes with what? Felix? Perfect. Yeah, the t's goes with the t, and then the number 100 goes with the number 200. Can I do anything else? Can I make it any further? Nope. All right, so let's say they are siblings, then in total, this is how much they'll earn. So if they work 1 hour, then they would make $32 in total. If they work 2 hours, then they will make $364 together. Okay. Last one. Let's take up this one as well. Explain why 2/3 x and 2x over 3 are equal. Right. Why are these two equal?
If you have a coefficient in front of a variable, it just means you're multiplying that variable by the coefficient. So that's just 2/3 times x, and that's obviously 2x over 3. And to simplify the expression, we can just convert it into the same denominator. So multiply the top and the bottom by 3 to get 6x over 9 minus 4x over 9 to get 2x.
Perfect.
What do you want from an explanation, though? That doesn't feel like an explanation. That sounds like restating the question. The actual explanation will be citing the axiom of arithmetic.
Yeah, so for these ones, remember whenever you're multiplying to the numerator only. the main common mistake that people do is when they multiply the x, they multiply it to the 3 as well. So people will actually do 2x over 3x, which is, as you know, not the case. So when you multiply a coefficient with a variable, you're only multiplying to the numerator. And then as Trinik said, to add or subtract fractions, you need lowest common denominator. And so in this case, when you have the denominator of 9, you can just add or subtract the numerator, as we said. And so you get 2x over 9. All right, so that was yesterday's homework. There were these challenge questions on page 4. Anybody want me to take up any of these ones? You're good? Okay, answers are given for the challenge questions here. So if you want to check if you got the challenge, it's right there. Okay, so today's lesson is just add, subtract polynomials, which we did in question number 19. Okay. Okay, so okay, so the number 1 and 2 may seem like really simple and easy, but I still want to go over it. So 3 plus 4 plus 5, when we drop the brackets, we can just write it as 3 plus 4 plus 5, which is 12. Okay. But what about this one? When we drop the bracket, why is it 10 minus 4 minus 3? Edward, is your hand up? No? Okay. Sure.
If you have a minus sign in front of a bracket, that's just multiplying that expression by -1.
Right.
So we just have to multiply 4 and 3 by -1 to get 10 minus 4.
Right, because it's minus this whole bracket, or in other words, if you think bad math, you're supposed to add the 3 and the 4 first before you subtract the 7. So when you apply that negative sign to everything inside the bracket, then you get the same thing as 10 minus 7 or 10 minus 4 minus 3, which gives you 3. Okay? Keep this in mind when you add or subtract polynomial. So this is the key idea, basically. Okay, so let's do this one first. This one, nice and simple. You're adding 2 polynomials. All right. I don't like the brackets, so let's drop the brackets. So this, I can just simply drop it. 2x minus 9. Since it's adding this, that means nothing changes. I can just copy the equation straight down, the expression straight down without changing any signs. I can just drop the brackets. Now I can group my like terms. Okay, 2x goes with the negative 5x. Remember yesterday we talked about the positive negative coefficient? All right, so the sign goes with it. So 2x minus 5x, what do you get? Aaron? Huh? 2x minus 5x? Negative 3x. Perfect. And then what is negative 9 plus 1? Sure. Negative 8. That's it. And that's your answer. All right. Let's try this one. Now with the minus sign in between them. So the first bracket, I can just leave it as is, because the first expression in the bracket, I'm not doing anything with it. I just do that. Applying what we did in example 2. Okay, now that I want to drop the brackets, what would my expression look like? What does the rest of my expression look like? Ryan? Right here?
Answer.
No, just this part. So if I were to drop the bracket?
Oh, that's just plus 8x minus 10.
Right. Good. Because I'm subtracting everything in the second expression. So in other words, I'm like changing the sign. Right? And then I can do exactly what I did up here. 6x plus 8x gives me the 14x. And then minus 5 minus 10 gives me negative 15. Okay. Let's see. Let's do. Okay, let's do a more complicated one. Okay, let's do number 10B. All right, let's do 10B. Okay, simplify it and then evaluate. So again, I have a subtraction. So that means I'm changing the sign and everything inside the second bracket because I'm multiplying the negative to everything inside. All right, so rewrite it with the brackets dropped. So 17y squared minus 15y squared minus 3y plus 8. Okay. Okay, simplify it. Somebody simplify this for me? Noel? Perfect. 2y squared. Can I combine anything else? Nope. So I just copy it straight down. Okay. Am I done the question? No? Okay, so Noel, what else do I have to do now? Perfect. And whenever I substitute, I have to put it in brackets. Good. So 2 bracket negative 3 squared minus 3 bracket negative 3 plus 8. And I will get my answer 2 times 9. All right, you can type all this into your calculator. So, but if you are relying on your calculator, make sure you type it in as is with the brackets. Okay, minus 3 times negative 3, right, Tensi?
Which one?
And you get the answer 35.
What question?
10B. I'm just getting your attention. Okay. Okay. So just one last example. With polynomials, there isn't much word problems teachers can think of. Teachers are not that creative. So the only type of word problems that they use over and over and over again are like questions number 12. Okay, what type of questions are like number 12? Perimeter or yeah. So on the test or on the quiz, you'll likely see a perimeter or area question. Okay, given these expression for the length and width, find the perimeter, find the area. I guarantee you're gonna see it in grade 9. You're gonna see it in grade 10 because it's the most common type of word problem.
It's also how they did algebra before they used letters.
Yeah. All right. So if I were to just do an expression for this, okay, for the perimeter, Tensi, since I have your attention, okay, how would I write out the perimeter for this one?
3 multiplied by x minus 4 plus 2x plus 5.
Okay, good. So, but if I were using today's knowledge on adding and subtracting polynomials,
What do you mean?
so if I were just to do like length plus width plus width, because tomorrow we're going to do multiply.
Oh.
Yeah.
2x plus 5 plus 2x plus 5 plus x minus 4 plus x minus 4.
Right. Yeah, I know a lot of you guys already know how to do multiply. Okay, good. And then so now I can add up all my x's. So 2x, 2x, x, x. So you get 6x, and then the 5, the 5, the -4, the -4, you get +2. Okay. Okay. Can x be a negative number?
No,
Why not?
since it's an actual rectangle.
Right. Since it's an actual rectangle with perimeter, what's the minimum perimeter you need for a rectangle? Like it has to be a positive number, right? So x cannot be negative because otherwise the whole question doesn't make sense. Okay. So area is length times width. Okay. So if I were to do this, this is actually grade 10 for polynomials. Technically, yeah, you could do it in grade 9 too. So 2x plus 5 times x minus 4. This would be the to find the area. So as an extension, you don't have to know this for grade 9. Okay, Rome.
You multiply 2x by x, so you get 2x squared.
Yep.
And then you multiply 5x, 5 by x, 5x, and you subtract it by 2x times 4 because it's negative.
Yep.
So then you get negative 3x.
Mm-hmm.
I'm skipping that question.
5x minus 8.
Okay, so plus 5x minus 8x, and then one last term.
So 5 times negative 4 is negative. Subtract by 20.
Right. Okay. So basically, you're doing the first term multiply the second polynomial, and then the second term multiply by the second polynomial. Okay. And then, but then looking at this, I could still collect like terms. So my final answer here would be 2x squared. Yep. Minus 3x minus 20. Right. Okay. Again, this you don't need to know. This is just extra. Okay. There is an acronym that we use for this. FOIL. Yeah. First, outside, inside, last. So multiply the first of the both terms, outside of both terms, inside of both terms, and the last two terms. Okay. This is just to help you remember to multiply all four. Okay.
Negative 2.5. Negative 2.5.
Okay. So that's the so that's the lesson for today. Adding and subtracting polynomials. So your homework up to page 9. So this ties into what we did yesterday with collecting like terms. It's basically the same thing, but now it's an expression plus another expression. You have more. Okay. Yes. So up to page 9. Again, there are challenge questions on page 10 if you want to challenge yourself. Okay?
Yeah, it's your first. It's